So this is Physics Extra Credit. I attended the lecture on the Higgs boson by Howard Gordon of Brookhaven National Laboratory in Upton, New York. My name is Casey Haynes. So the first thing that he talked about was the four forces in nature, which is very relevant to what we've been learning in physics. Everything that we learn has to do with the four forces in nature, and the four are strong force, which consists of quarks, nuclei, mesons, baryons, the weak force, which are bosons and neutron decay, gravitational force, which we're all familiar with, it's on the Earth, solar system, and electromagnetic force. And we're going to focus on the weak force, mainly bosons. So what is Higgs boson? Well, in the 1960s, Peter Higgs proposed that all of space is permeated by a field. And quantum theory says that all fields have particles associated with them, in this case, the Higgs boson. So what does that mean? What's the Higgs boson? Basically, it's the particle responsible for giving mass to other particles. For example, if you were at a cocktail party and a famous person walked in the room, as that famous person walked through the room, all of the other people would go up to the famous person, and that person would start acquiring mass around them. And that's what the Higgs boson does. As it goes by and particles gather, they gain mass. So why is it important? Well, if the Higgs boson proves to be true, then it would complete the standard model of physics, which is the theory that describes the four forces, which we talked about earlier, the strong force, weak force, gravitational force, and electromagnetic force. And this would also explain why electrons have mass, which is something that physicists have been puzzled about for a while. So bosons are a type of particle and have an integer spin of 0 or 2. Vector bosons have a spin 1, and then there are lots of other types of particles. There are fermions, quarks, leptons, but the Higgs boson contains bosons, and bosons are particles that give mass to other particles. So how does this relate to particle physics? Well, in particle physics, they use a standard of 5 sigma, which means that when conducting research, if you have a standard of 5 sigma, that means that there's one chance in 2 million that the result is wrong. And so particle physicists have been using 5 sigma to help them understand the Higgs boson. And a particle consistent with the Higgs boson has been discovered in 2 independent experiments in CERN, which is the European Organization for Nuclear Research, with the Large Hadron Collider. So the likeliness of this Higgs boson is pretty high. So here's a picture of the Large Hadron Collider. And what the Large Hadron Collider is it's the largest and most powerful particle accelerator in the whole world. And it can help us prove that the Higgs boson exists because it accelerates particles, allows them to interact. It's a 27-kilometer ring of superconductor magnets kept at a temperature of negative 271.3 degrees Celsius, which is colder than outer space. Another name for the Higgs boson is the God particle. And recently, scientists believe they finally discovered the elusive Higgs boson particle. Now, while the Higgs boson is fundamental to the universe itself and to the standard model of physics, it is unclear what type of result it will have on the human race. And scientists are going to look further into how understanding the God particle will help us understand the world around us. So thank you for watching.